Hello everyone. Since 13.3 is not part of your syllabus, we'll move to 13.4 basic rules for determination. So since you must have studied determination in class 12th as well, so I'll just go over it again. So if we have one row or one column in a given matrix as 0, that is all the elements of a row or a column are 0, then A determinant would be equals to 0. Second, A determinant equals to the determinant of A transpose. Now if we have a matrix B which is defined as alpha times A, where alpha is any real number, then determinant of B is alpha times determinant of A. So these observations you must be able to recollect. And if two rows or columns of a matrix are interchanged, of matrix A are interchanged, then the sign of the matrix changes. So the absolute value would remain same, but sign would change. Now similarly, if there are two rows or two columns which are equal, then A determinant equals to 0 if they are equal. If two rows or two columns. Similarly, if two rows or two columns are proportional. So suppose we have a row 1, 2, 3 in a 3 cross 3 matrix, and the second row is 3, 6, 9, and here it is suppose 4, 33, 10. Since these two rows are proportional, so the second row is 3 times row 1. So in this case, determinant A would be 0. Okay, now if the sixth property is, this was the sixth, this is the seventh. I hope you would be able to recollect this. Now if a scalar of any row is added to another row, suppose we make a transformation, r1 goes to r1 plus alpha r2. We'll discuss this in detail when we study about elementary row operations. So in this case as well, the determinant would remain the same. So if you're making any linear transformation in it, it won't change the value of determinant. Now if we have A and B are two different matrices, then the product of AB, then the determinant, so AB is the product of A and B, determinant of AB would be determinant of A times determinant of B. And lastly, if alpha is any real number and A is a n cross n matrix, then this would be determinant of alpha A would be alpha times n, where into determinant of A. So this is a important property that you might do wrong in the exam. Okay, now just a small example. Check that AB determinants equals to A determinant, B determinant. Okay, so suppose starting with what AB would be. So this is first row into the first column. So this becomes 3 minus 5 minus 5 minus 10 plus 3 is minus 7. The second element would become 1 into 0, this into this, then 5 into 1, 5 minus 2, 3. The third element would become 2 minus 3 minus 1. Now this would become minus 3 minus 1 minus 4 plus 15 11 0 1 plus 6 1 plus 6 is 7 minus 2 plus 9 7 9 minus 2 7 plus 5 12 0 2 plus 2 4 6 plus 3 9. So this is AB. Now we'll find what AB determinant is. Minus 7 into, so product of this minus product of this, minus 7 into 63 minus 28 minus 3 into minus 63 minus of minus 12 is plus 12, then minus 1 into 44 minus 84. This comes out to be minus 7 into 35 minus 3 into minus 51 minus 1 into minus 40. So this becomes 35 into 7 245 minus 245 plus 153 plus 40, so basically 193, so minus 52. On the other hand, so we have AB determinant equals to minus 52. Now looking at A determinant, so you know how to find A determinant as well and B determinant as well. So I'm giving you 2 minutes to solve this and just verify whether the answer is coming out to be same or not. So this is a basic example, so I would expect you to do it. So it is 7:56. I'll give you till 7:59 to solve this. And try to expand the, to find the vector, to find the determinant of B, try to go through this row or this column, because one of the element is 0, it would help in simplifying the calculation. Okay, so try to complete it by 7:59. Okay, so since B determinant is quite easy to find, expanding through this row, it is 3 into 3, it is minus 0 into something which would be 0, plus 2 into minus 2 minus 5. So we have 9 plus 2 into minus 7. This is 9 minus 14, which is, so this is minus 2. Okay, I'll just do this again. 3 into minus 2 minus 5 minus 7. This is 9 minus 14, which is minus 5. Just try to find A determinant. I'll just verify this as well. 3 minus 5 minus 5 minus 10. 5 minus 2 3. Okay, so this is correct. And if B determinant is coming out to be -5, so accordingly we'll see A determinant would come out to be, since -52 equals to A determinant into -5, A determinant would come out to be 52 by 5. So you can just verify this. There might be some calculation mistake, but if you'll solve this, you will be able to verify this. Okay. Now moving to an important concept, involutive matrix. So what is an involutive matrix? When, if you're talking about a square matrix A of order n, so it would be called involutive if A square equals to the identity matrix. Okay, so check whether the following matrix is involutive or not. So in this case, A square would be A1 1 minus A square minus A. So this should be identity equal to identity matrix. So of order 2 would be this. So we have A square plus 1 minus A square, then A into 1 minus A square plus 1 minus A square into minus A. This is A minus A. This is 1 minus A square minus 1 minus A square plus A square. So this is coming out to be, this would cancel out. This becomes 0, 1, 0. This whole term would cancel out, 0 and 1. So we are getting the identity matrix. So this A matrix is involutive. Okay. Now moving forward. So now finding the determinant using cofactors. So this cofactors you have already studied. So I'll just do a simple question that would be sufficient. So the Cij, the cofactor for ith row and jth column, so it is -1 to the power I plus j times, now this is the n cross n matrix, so we'll remove the jth column and the ith row, and then we'll find the determinant of the remaining elements. So this would be Cij, -1 to the power I plus j times the determinant. Okay, now to finding the determinant of the whole. So it is ai1 ci1 plus ai2 ci2 till ain cin. So this is expanding along the ith row. So in this case, we are expanding it along the ith row. Okay. Now moving forward, the inverse of a matrix. So, okay, the first thing is the inverse exists only for a square matrix. Yeah, because then only the determinant is possible. So given matrix A, if there exists a matrix X such that AX equals to XA equals to I, then we say that X is an inverse of A. So for any given matrix A, if we have a matrix X such that AX equals to XA equals to I, then we say that X is an inverse of A. Now some important points. If a square matrix A is said to be singular, if it is said to be singular, then that means determinant A is 0. It is called non-singular if determinant A is not equal to 0. And for a 2 cross 2 matrix, the determinant of A is, the inverse of A is 1 upon, this is determinant A, and these diagonal elements are interchanged, and the off diagonal elements, the sign of them interchanges. So minus B, minus C, and they have changed. So for 2 cross 2, this is a more convenient formula. Now some of the properties of the inverse. Let A and B be invertible n cross n matrices. Then A inverse is invertible. If A inverse is invertible, then A inverse, so inverse of A inverse would give you A matrix only. If AB exists and they are invertible, then the inverse of AB is B inverse A inverse. And if A transpose is also invertible, then the inverse of A transpose would be inverse of A then transpose of it. So these are the basic properties only. So if C is any real number, so C times A matrix, inverse of it would be C inverse A inverse. C should not be 0 because then it would come 1 upon 0, which won't be defined. Now moving forward, solving equations by matrix inversion. So we know how to write the general equation in this form, where B was the right hand side, A was the coefficient matrix. So pre-multiplying it by A inverse, so we have A inverse A, x equals to A inverse B. So this becomes I, so we have x equals to A inverse B. Now solve the following system of equations. So here we have A equals to 2, 1, 2, 2, B equals to 3, 4, and x equals to x, y. So Ax equals to B, so x would be equals to A inverse B. Now for 2 cross 2 matrix, we know how to find A inverse. A inverse is 1 by A determinant into adjoint A. So this becomes 1 by 4 minus 2, 2 into adjoint A. So A is 2, 2, 1, 2. Adjoint A would be interchanging these rows, these diagonals, same thing, minus 2, minus 1 times, okay, so this is A inverse. So x would be this. So if I take 2 inside, it would be 1 minus 1 by 2 minus 1, 1 times B, 3, 4. So this would be 3 minus half into 4 upon minus 3 plus 4. So this gives us 1 and 1. So if you will substitute it, you will get it. So x is coming out to be 1 and y is coming out to be 1. So you can just put them in this equation as well to find whether the solution exists, whether the solution is correct or not. Okay. So now, so basically we have discussed about 2 cross 2, but this exists for n cross n matrix as well, that A inverse equals to 1 by A determinant into adjoint A. And we know how to find adjoint A. So we'll find the cofactors C11, C12, C13, then C21, C22, C23, C31, C32, C33, and then make a transpose of it. So 1 by A determinant, and this thing would give us the adjoint of A. Okay, now moving forward, so suppose A matrix is given to you, you are supposed to find A inverse. So A inverse would be 1 by A determinant into adjoint A. So I would suggest you solving this question at least. Okay, so I'll solve this question. Now A determinant, suppose we are expanding it through this row. So this would be 2 times 3 into 4, 12 minus 2. So plus minus 3 times 16 minus 1 plus 4 times 8 minus 3. This is 20 minus 45 plus 20. So this is coming out to be minus 5. So A determinant is minus 5. Now talking of adjoint A. So before C11, C11 would be 12 minus 2, 10. C12 is 16 minus 1. So with the sign of minus, 15. C13. So 1 plus 2 was 3. So minus 1 to the power 3 is minus 1. That is why we have the negative sign. So you must know this by now. Okay. Then C13, 8 minus 3, 5. C21, 12 minus 8 minus 4. C22, 8 minus 4, 4. C23 with a minus sign. 4 minus 3, 1. C31, 3 minus 12 minus 9. C32, 2 minus 16 minus 14, since 3 plus 2 is odd, so minus of minus, so minus already. Then 2 minus 16 minus 14, so it would be plus 14. Then C33, 6 minus 12 minus 6. So A inverse would be 1 upon minus 5 into adjoint A. So this would become the row because we will do transpose of it. So these rows would become the columns. So this would be 10 minus 15, 5 minus 4, 4 minus 1 minus 9, 14 minus 6. So this would be the A inverse, and you can multiply this with A, and if you are getting the identity matrix, then it would be verified that our A inverse is correct. So far these things what we have done, we have already covered this in class 12th as well. So one mistake that you will make is कि calculation हो जाएगा. I'm telling you, even if I'll do calculation right now, I'm bound to make some mistakes. So if you are supposed to find A determinant, do find it. If you're supposed to find A inverse, do find it, because it will help you a lot in the later part of the course. Okay, so I'm done with this. In the next class, we'll study in finding inverses by elementary row operations, and this is important. So I'll be focusing on this in the next video. Okay, thank you.